Alright, so I got this question from a student at Algebra 1. I really like this question, so I want to talk about it. But before I can start solving this, I want to at least see what it's asking us to do. And I've noticed here I have my bases, quite a variety of them, right? I have P, I have Q, and I have R. And what it looks like it's asking me to do is evaluate whether or not this is true potentially. But then I noticed when I looked at the bottom, it wants to know what is the value of n. And that got me looking at it again, and I saw that our exponents have a variable in them right here with this n, and that's pretty interesting. So then what this question is really asking us to do is, for what value of n does distributing this qn result in q to the fifth? But I'm not going to jump straight into that. I want to talk about how to do this whole problem, and then how we're going to determine what value of n makes this true. So before I do that, I have to know a couple rules, and I'm going to put those in purple here. If I have a base that has a to the m is just some other variable. It could be 3, it could be 4, it could be 5 or 7. If I'm going to multiply that with another one of these, they must have the exact same base, and then they can have any exponent. And if I do that, I'm going to end up with, well, so the rule for this is if the bases are the same, so we have a and a, these are our base. Let me write that for you too. So we have a base to the exponent, or power, depending on how your teacher says it. But, so here's our base, here's our exponent. If I have the same base and I'm multiplying them, I can just add the exponents together. So here, for example, I have P, and I'm distributing it into here. P is only going to impact the ones that have a base of P. And since I have P to the third, let me change the colors, times P to the fourth, I can just do P 3 plus 4 to get P to the seventh. And we can see that they have that result right here in P to the seventh. So now what I have to ask myself is, for what value of Q, let me not use that color again, for what value of Q, or what exponent of Q here would make this become a 5? So what I have is Q squared times Q to the n, and I want to know how do I make that Q to the fifth. So what I can do is, looking at just the exponents, 2 plus what number equals 5, and I'm going to subtract 2 from both sides, and I get n equals 3. So for now, I'm going to move up here and put n equals 3 in the box, but I'm going to check that before I actually submit my question or answer that in our, I believe this is on Algebra Nation or Math Nation. So now what I want to do is look at, I said n is equal to 3, so I can rewrite this as P to the 3, Q squared, P to the fourth. And now here we're going to make that substitution for n. Put that as a 3. This is r to the third over r to the negative 4. And we're going to see if we do end up with this when we distribute the qn. Now, you'll notice I never did anything with the r. That's because I don't have an r out here as a base to multiply. Remember, to multiply these, the bases must be the same, and then we can add the exponents together. And I'll show you why that is the case as soon as I finish this part of our check. So really, I'm concerned with the values of q. So here I have q squared times q to the third. And following this rule, this is just q 2 plus 3 for a q to the fifth. And that is the answer that I was aiming for in our problem. So let's look at why we must have the same base when we're multiplying together and why we're able to add them up. So let me do, oh man, I'm just going to do a whole new file here. Nah, we're not going to save it. So I said if we have the same base raised to any exponent or any power, and then I multiply that with any number that has the same base to another power, I can just add them together. So I'm just reestablishing the rule before I try and show you why this rule works. So let's do something here. Let's say A is equal to 2. So we have a base of 2 here. We're going to put M to equal 3 and N to equal 4. So if I rewrite this using these parameters, I will have 2 to the third times 2, same base, to the fourth. And what I'm saying is, because they're the same base, even though we're not using variables anymore, right? I made my substitution for A equals 2. These are the same base, so I should be able to get 2 to the seventh here. And what does that look like visually? 2 to the third is just 2 times 2 times 2. Then I drop down my multiplication, and then I have 2 to the fourth, so that's just 4 more 2's. And if I add all these up, I have 1, 2, 3, 4, 5, 6, 7. So I'm giving you the proposition that this should equal 2 to the seventh. Now let's actually check that, and we're going to do it 2 different ways. Alright, for the sake of speed, I'm going to pull up my calculator. I have it set to scientific so that I can use exponents. And I'm going to test this one here with the blue line under it first. I'm going to do 2 to the seventh power, and I get 128. Now, what I've shown you here, right, 2 to the third one more time is just 2 times 2 times 2, and 2 to the fourth is just 2 times 2 times 2 times 2. So now I'm going to do it 2 other ways with my calculator. 2 times 2 times 2. Alright, so let's look at what 2 times 2 times 2 is. That gives me 8. So 2 to the third is 8. And then I have times again, because I'm going to carry this up. And then to get 2 to the fourth from 2 to the third, I just have to multiply by 2 one more time, and I get 16. And now if I want to know what 2 to the third times 2 to the fourth is, I can go back to my calculator. I already have the 16, so I'm going to hit times 8, and I get 128. So now I've got 2 times, or I found the answer to be 128 2 different times. Another way I can do it is, remember, when I multiply two numbers that are the same together, it increases their exponents by 1. So just like I broke 2 to the third apart, I can put this back together by counting the number of 2's and then raising my base of 2 to that exponent. So there's 1 here, 2, 3, 4, 5, 6, 7. So that's 2 to the seventh. And I've already shown that 2 to the seventh is 128. But this is just another way to look at that. So I hope this was helpful. I hope that you watched the video all the way through, even though we started with the answer. And I hope you have a better understanding of what we do to multiply numbers who have the same base but different exponents.